Okay, should be live now. So I'll check with the stream in a minute to make sure everyone can hear us and can see us, but we're going to get started. Really quickly before Sam jumps in and does his talk, I want to go through some of the things that we usually go through, which is what's coming up on the schedule. So we have Sam today with Parsing C code. Then next time on the 14th, we'll have a talk on Swagger. And then after that, on the 28th, we'll have a talk on practical accessibility for web and software developers. Then after that, we'll have the diversity and IT talk. And I believe on the 26th, we'll have our Dev Group social where we have the lightning talks and the good food as well. We still have openings for that. If you guys want to give lightning talks, please let me know. Let me know what the topic is going to be, and we can fill in those sessions there. Thinking right around between 5 and 10 minutes per talk. So that'll be really good. Other than that, I think that's more or less all of that we have. I'll be probably out more in the next couple of weeks because we're having a baby in the next probably couple of weeks. So the more help we can have with the dev group, the better. That way we can make sure this thing runs smoothly, even if I'm not there. Today it seems like it ran pretty good, but we can still work out some more kinks as well. So other than that, I'll turn it over to Sam and the guys in the room and let you guys take it away.
All right. I'm Sam Price. I've been working on flight software for our GPS receiver that's on OMS and GPM. After struggling with doing Word documents for our interface control document, I decided I was just always going to do all of our command and telemetry documentation through parsing our C code and then generating our RDLs for the command and telemetry database and also for the documentation. So this is kind of the route that I settled on, using Clang to parse our C code and then a Python interface to Clang to generate the final products, if it's sys database or an interface to MATLAB for our flight software, stuff like that. Has anybody ever used Clang to do compiling embedded software? So Clang is a front-end LLVM, which is a compiler similar to GCC. I believe Apple and Google are doing the development on it. It's BSD compared to GCC that's not BSD. And they have a couple interfaces to it. They have a C++, it's written in C++, I believe. And then they have a C interface to it that allows you to call into it from other languages. So we're going to use libclang to do this. And Y processor C code. I use it to generate our command and telemetry definitions. We also use it to find all of our function calls inside of our flight software and generate MATLAB APIs to call into our flight software so we can test our flight software and interact with it from MATLAB. Also, if you get like an existing code database, like if you got the CFE and you want to go and find all your telemetry packets inside of it and then create a command and definition database for Cosmos or one of the other RDL command and telemetry software packages, you could do that. So the Python bindings, you can find them off of their GitHub website. If I can get my mouse to it. And then they have, I'm trying to find the mouse. Here we go. So they have the C index file, which has all the function calls into the shared library Clang, which is a compiler. So you can interact with the compiler from Python through this interface that they have. Okay. And then you call a get cursor from file and you give it a file name, and then you give it the same arguments that you would compile in CCC. So if you want to change your padding or alignment, you can pass the M32 flag and it'll change your parsing from 64-bit to 32-bit. So if you're switching platforms, you can pass different flags. So, or if you have different pound defines in your source code, you can control that so you get exactly what your compiler is seeing in your source code. Do we have very many C++ developers in here, or C developers? So there's a lot of different ways that you can define a C structure. So the Linux version is you define the structure, and then you type struct, I think it's type def struct A, and then the definition name. I have a spelling mistake up here. But, and then also you can do the type def. And then there's a third way you could do it, and a fourth way. So there's lots of different ways you can define structures in C++ or C. So writing your own parser is probably not something you really want to do. So if you can use an actual compiler to parse your C code, then you don't have to worry about all the semantic problems that you're going to run into. So this is an example where you get a cursor from C-lang, and a cursor is kind of like an individual point in your AST tree, which is an abstract syntax tree. So when the compiler parses your C code, it kind of makes this tree of all of your nodes and tokens and stuff. And this lets you transverse that tree. So if I run this example, and then you loop over all the children from the top cursor, you get the struct definition, a variable declaration, a type def declaration. So it gives you the whole tree, and then you can print off stuff like how many children each one of these elements has. So if anybody has questions, ask me, because I didn't have a lot of time to prepare for this.
They specified the cursor. What was that? Your description there as far as the cursor?
This cursor?
Well, not so much just the command statement, but you sort of touched on what your cursor actually defines. What how it's.
So it's a node inside of the AST tree, the AST tree. You're familiar with that?
Oh, okay, that's what you said. Okay.
Yeah. So, it lets you loop through that tree, and then you can inspect it and see that it's a structure or a type def, and then all the structures will have children. Like, so this struct A had 2 children. This was a variable declaration for the global A1, and then you had a type def structure. So it just gives you a brief overview of what's inside your source code.
So it says, I'm trying to spot the bug on the page.
This one?
Yeah.
Yeah. There's I think it's supposed to, there's supposed to be a type def here, I believe. I'd have to fix it on the source code. But. It was supposed to say type def struct, I think.
Mm-hmm. Okay.
All right. So that cursor object has a lot of attributes that you can interact with it, see stuff. So I'm just gonna. So usually when I do a development, I run IPython, and that lets me interact with the when you run that, it gives you all these macro definitions, which are from the compiler too. So one of the fields is the location. I'm not displaying that. Sorry.
I think we lost him for. I'm going to try to see if I can reconnect with him. Just give me 1 minute. Looks like we got you back now, Sam. Thanks.
Sorry about that.
No problem.
Like cursor objects is that you look at all the elements. So the next thing is to process the structure and see all the child elements out of it. This one. This is the source code, and you can parse through this, and then it gives you, for each of the child elements, it's giving you the byte offsets. So if you're trying to make definitions, you can get the padding bytes offsets. If you change between M32 or M64, it'll change the padding offsets. So it kind of takes care of that all for you, so you don't have to guess at that stuff. And then it gives you the type kinds and then the spellings. Then the source code that does that, it's this guy. We're skipping all of the elements that have no location, which is like the system macros. And then we're only looking for the structure declarations that would have children. And then you run in there and then you grab all the children off the structure. And then you print out the attributes that you're interested in for each one. So that's.
Can you cross compile on the different architecture?
Yeah, so you pass in the -M32 flag.
Okay.
And that'll give you a different, yeah, that'll give you a different padding byte offset. So if you pass an M64, then it changes to 64-bit line.
Makes sense. Okay.
The Indianness, I'm not really sure about. I think you can probably specify the Indianness, but that should only affect your bit fields, I think.
Yeah, that makes sense.
So.
That'd be my next question. Thank you.
Let's add. Okay. And then the next trick is sometimes you declare structures but use type defs for the names. So if you want to trace a type def back to its parent type, let's go forward. You do a check to see if it's a type def declaration, and you can grab the spelling, and then you have to grab the canonical type, which I'm not really sure what they meant by canonical type in the Clang definition. So still looking that up. And then you grab the declaration, and then you can process the structure like normal. So. So there's all these cursor kinds, and then there's all these different types. That they'll give you back when you're parsing through the AST tree. there's like the type def reference, declaration. And then the other part is types. And they have kinds also. And these are really easy to get confused about. You have to make sure you separate cursor from a type and don't mix the two when otherwise you're gonna get confused. And what they say, according to the Clang website, so a cursor represents a spot in the ASCII tree, and then a type is an underlying type definition. And I'm still, sometimes I get confused about the two, so I'm still working through it. But, so the next part is arrays. So again, you loop through all the children, and then you find something that you're interested in. And then I'm going into that loop, and then you can get the size of an array, and then you grab the next underlying type of it. So if you have a multi-dimensional array, you can loop through and grab all the type sizes and then print out. So this is a array that had a single dimensional, and then a double dimensional that was a double, and then that was these guys. So let you go through and just interact with all the. So one thing that I run into in some of the assist or RDL definitions is they only support single dimension arrays. So I'll parse through my C code, and then I'll grab all these and multiply them together to just create one large vector array for the other system to grab our telemetry with. Macros I didn't write about, but it can parse and decode macros. So I think I'm going to move into a real life example where so inside my flight software, I tag all of my structures that are going to be commands for telemetry with a in-group flag. And then when it parses through, it looks to see if that flag is inside the comment section. So if and then the first field I tag it with, this is the CCSDS header, packet header. So that's a standard packet header that goes on top of every packet. And then I tag up all the app ID I'll put in the comment section. This is a pound define, so if I want to recompile with a new app ID, when I parse the C code, I can just automatically grab new app IDs and regenerate in its telemetry table. Same with the command ID, so if I add or remove commands, and it moves the command IDs around and look those up. And then so this is a script I made that will parse through any CFE code and then it looks for the first field inside of all the structures to see if it's going to be a CCSDS packet or either a telemetry or a command. Let's see. So again, I grab the cursor from the file, loop through all the children. You ignore any ones that are system ones. You ignore any cursor objects that don't belong to the file you're trying to process. Decoding type defs. And then you get to children and you want to loop through and you want to look at the first field inside of a structure to decide if it's a CCSDS packet header or a command header. And the reason you have to loop through them is the first few might be attribute flags, like if it's packed or the padding on it. And then I had a function that decides if it's telemetry. And that goes through and it looks to see if it's a constant array, grabs the tokens, and it sees if any of the tokens are the command header size or the telemetry header size, or if the first object type is a structure that's a CCSDS type structure. And then I create a database of all these that I can then use to decide, parse later to generate definitions. So this went through all the C code, and then it generated up all the structures for the C type, the command string, the app ID string, and then what file this packet came out of, and then it grabs the type if it's command or telemetry. So this next script goes through all the source code, and it decodes all these app IDs and the app ID and the command IDs, and then puts these numbers inside of the telemetry and command database. The way that works is so it looks for all the macro definitions, and then I build a lookup table of all the macro definitions, also for the enums. And then I have a script to expand the macros, which just basically goes and grabs the macro and then generates it to an integer value. Which is kind of more complicated when I go over, but it basically turns it into that grabs all the tokens for that macro and then expands them out. And then it uses an eval function that I probably shouldn't use on it, but makes it easy. So. Is there anybody that has like use cases that they'd want to see this with, or questions? No? Okay.
How does it dynamic parts?
So can you give me an example? Like,
So instead of a constant array, variable length array.
so this is,
CCSDS has it defines that.
yeah.
Sam, can you repeat the question for the people online? We didn't hear it.
So I'm kind of running out of stuff to talk about, but I was just wondering if anybody had questions about that. The way I would deal with that is,
Repeat the actual.
oh, the question.
You were asking.
Yeah, he was asking how would you deal with dynamic arrays. So in assist or some of the CCSBS packets have dynamic arrays that are defined inside the packet.
Variable length.
Yeah, so the way I would deal with that, I'd create a packet, and then you'd have like 32, and then you'd have like the header up here, right? So let's say that's your packet, and you want this to be in a dynamic array. So what I usually do is I'll do what I do is I tag my fields inside the structure. So I'll give it tell it it's an array, and then I'll say it's variable length. And then when it's generating the CCSDS packet structure for your command definition, it'll automatically see this variable flag and then add it to your, I don't know, however you're defining your RDL database. Does that make sense?
I guess so. So like, I'm not that familiar with Clang. I was just more curious. So if you define it as variable length, so then the packet size can vary, right?
Yeah, so C-Lang is just a C compiler. It's not like semantic definitions. Is anything that's not inside like the C library, I put in my comment section as a parsable comment. And then it's up to the tool that you're generating that's parsing your C code to see these comments and then just add those flags to your output.
Okay, makes sense.
So for this, then I missed a little bit in the beginning when you're describing what you're using this for, but it seems like you have access to both the C code and as well as your Python code, so you can add those attributes into the C headers to help with the parsing when you're converting into an AST. Is that correct?
Yeah, so I'm actually generating lots of products from my C code. So I'll generate, there's like assist, which is our command and telemetry databases that take the data from the embedded system and then they display it on a display. And they have, it's the same encode. So the C code encodes it based on how you have your structure set up, and then assist has to know how your packet's set up to decode it. So you have to generate this other same representation of your C code into the assist using their own semantic format. So this being able to access all your variables, the padding offsets, that lets you generate another language's definition of your C code.
Oh, okay. I get it now. So
But they also,
go
yeah.
once and have this adapter layer adapted to the other endpoints.
Right. But they'll also, like, the other endpoints have more information than the C code needs. Like, they might have limits. So, like, you'll get a red limit, warning limit. And I go into my C code and I add comments on all my fields that have limits, and I'll be like, red, I don't know. So I'll add limit high, I guess. I'll make up my own semantic comments, and then, I don't know. So if anything goes above 100, then it's supposed to generate a red limit inside the assist database that says if it goes above 100, then it creates a warning.
Okay, that makes sense. Okay, I think I follow now.
Yes.
But given all the constraints or all the tags you had to sort of synchronize, how long do you think it took you to kind of to get the Python script, set up so it could basically handle all of the C tags that you have? I mean, I'm assuming, as you said, you're basically spitting out a number of products.
Yeah. So
that's a lot of lead work, the head work. So,
the interface to parsing like the C code is fairly straightforward.
Yeah.
So you just have to sit there and fiddle with it.
okay. So setting it up, wasn't as labor intensive as it seems.
Yeah, it's way bit easier than parsing your own C code, because you just loop through and you're like, is this a structure? Okay.
Right.
Grab the first field.
Yeah.
Guess I can. Another thing is it can grab functions and tell you functions. So if you want to generate a MATLAB API to your C code, you can go over that.
I know a lot of that metadata usually goes in the commenting and that kind of thing. Is standard. One branch to another.
I know a lot of people are trying to do electronic data sheets, but then you end up writing something in XML, and then you need a tool to go into XML to grab it,
Exactly.
and it's not human readable. But if you put it in your C code, then a lot more people already know C code, and you can reuse the existing code. Also, if you change your compiler to M32 or 64, it changes all your padding bytes if you're not careful. So in my mind, this made more sense.
Sam, I think you said you're converting the structs and everything to an AST, and then outputting that to like it looks like JSON or something like that.
Yeah.
What's the difference between doing that and maybe just adding an adapter layer inside your C code to output the JSON for the corresponding structs? Like the thing that you're mentioning not just now with the functions, that would be cool. But if we're just talking about the structures, why not create an adapter layer in the C itself to output the JSON that you need?
I usually do go straight from the C code to the target language. You could go to JSON, but I don't know. I usually go to JSON just for like the app ID and command IDs, and then I reuse that all the time for generating the actual definitions of the structures and not.
Okay, so the JSON's not the output. The JSON's just a middle step in between converting it to the other language.
Yeah.
Okay.
This is a MATLAB output that I went and found a C function that was the set the ionospheric bias. It took in 2 command arguments, and then it outputs a status flag. And then based off those, the first one, it creates, MATLAB has this variable argument interface, so it saw that there was 2 arguments on this guy. So if you don't pass in both arguments, then it gives you an error message. It calls the function call with it, and then if it returns a negative number, then it actually throws a error inside MATLAB. So that's like one example, is you can kind of customize your interfaces from other languages into your application.
I have a question.
Yeah.
Something you showed earlier was you were outputting all the objects that you had.
Yeah.
You dumped all the objects I have, here they are. Could you pair that up with your function lookup as well and say, oh, these are all the objects and here's the functions that use them or talk to them?
Yeah.
Could you stick those together?
Yep. So that's one of the things I did was I scanned for all the times that the CFE calls like create a CCSVS message, and it finds that app ID, and then it can find like a structure that is already known to be a command or telemetry structure, and then it can pair those 2 up. So that's one way you can scan your source code and create a quick database of all your telemetry from an existing code base that doesn't put comments on their stuff. Is that answered? Or?
I think so.
Yeah. Can kind of
speaking in terms of dependencies, right? Pretty much like a networking sense. If it pairs it up or shows any links between callers and
So this is a function call, process function. It's not the calling expression. All right. So this looks for, this is the CFE software bus initialized message. You grab all the tokens for this thing. ID string. Okay. And then it's looking for the pound define that describes the app ID that you're sending out. It's been a while since I wrote this routine, but I did do this in here. So that makes sense. So another thing I did was I used this to generate Python API definitions of all my command and telemetry, and then I used that to decode all my binary telemetry coming through. So, but if you're web guys, then you can take that same definition, generate JSON data of all your telemetry coming out of your system. So it's an interesting topic, but didn't put a lot of time into the slides. But. Should I shut it off?
So Sam,
Yeah.
what other use cases could you see for using this conversion, this method that you have here?
One thing that I do is I make my interface control document. I have all my commands and telemetry, and it auto generates the command and telemetry document for our source code. And you pass that off to whoever's going to use our final product, which is usually, like last time we did this, we had a Word document, and we were never really sure if that Word document matched what was in the software. Things work. Okay. One way. There's a thing called Swig that does something really similar. You heard of that? Or no?
It sounds a lot like what Swagger does, which I think is the topic the next time around.
Okay.
Yeah.
The Swig will also parse C code and then generate API interfaces for Python or other things. It's written TCL, I think. I want a little bit more control to be able to generate my end products than this thing does. So
That's cool. So that means you can automatically generate your documentation so that you know it's up to date. It's current with what the code base has.
yeah.
Okay, that's cool.
Let's see if this builds. Why not have this set up right? Oh, so this is our ICD document that gets generated. So we have our offsets of all the packets and then data types. I don't know. That's how we're generating our ICD document. So.
That's pretty cool.
I got an example book if anybody wants to look at it. But.
there are any questions online, let me know and I'll relay the message over to Sam.
I have all my source code on the AEDT GitLab repo. So I'll post that if you want to dig through that.
Sounds cool. Okay. I don't see any other questions flowing in.
Okay.
So, Sam, thanks a lot for presenting. Again, let's see, switch over to sharing my screen. Not probably what you want to see. So again, that was Sam with the Parsing C code. I think next time around, we're going to have, I'm always butchering his name, Hedgedy. And he's going to be talking about Swagger and the Open API. That's oddly enough pretty similar to the documentation portion that Sam was just mentioning about the generating your documentation from comments and auto generating it, so you're sure that it's in line with your current code base. I think they can also generate clients as well using that Swagger API. So that should be pretty interesting, kind of a follow-on to what we just ended up talking about today. Again, if you want to give a presentation, it can be, however long. Just let me know and we can fill in the other time. You don't have to be an expert on the topic. You just have to be willing to get up and prepare a few slides or prepare a presentation for us, and it'll work out. So with that, I think if there's no other questions in the room, we'll go ahead and end the broadcast now. All right. Thanks everybody for coming out, and we'll see you guys next time.